Welcome back to our Smart Garden adventure. In the last module, you learned about different sensor types and how your soil moisture sensor works as we continue to build our amazing smart garden.
And by the end of this module, you'll learn how your smart garden makes decisions. We'll introduce the microcontroller as the brain and the water pump as the muscles of our automated system.
Meet the ESP32, the brain of your smart garden. This powerful little computer acts like the garden's brain. It takes information, makes decisions, and tells other parts of the garden what to do.
So, how do these things all work together? As you recall, then our soil moisture sensor functions like the garden's finger, monitoring the water levels. If the soil is dry, then that sensor sends an electrical signal, a message, to our ESP32 microcontroller.
Our ESP32 microcontroller then receives that information and makes a decision. It then relays the decision back to the water pump, which turns that information into action. The action is for your water pump to irrigate your plant.
It's similar to a relay race. Each part passes the instructions like a baton. The sensor takes the first leg, passing the signal to the microcontroller.
Now let's talk about another important part of the MOSFET. Your ESP32 passes a signal to the MOSFET. Think of the MOSFET as a gatekeeper for current. When the MOSFET gets a signal, it opens a gate and allows electrical current to flow through your water pump, turning it on.
This is done through inputs and outputs. An input is information going into the microcontroller, like the signal your sensor sends when the soil is dry. An output is information leaving the microcontroller, like the signal telling your MOSFET to turn on the pump.
To see this in action, let's jump into Tinkercad circuits.
Alright, let's take a look at this simple circuit. We have a push button and an LED connected to an Arduino. The Arduino acts like a mini version of your ESP32. When I press this button, it acts as an input. It's like sending a message to the Arduino's brain saying, hey, something just happened here. The Arduino's brain receives that message, and based on the simple instructions we gave it, which is its code, it thinks, oh, the button is being pressed, so I need to turn on the light. Then the Arduino sends an output signal directly to the LED. This signal is like a command telling the LED to light up. And just like that, we can see the LED turns on.
Now watch what happens when the button is released. The input message changes. It's like telling the Arduino, okay, the button is no longer being pressed. The Arduino's brain processes this new information and sends a different output command to the LED, turn off.
The circuit is simple, but it demonstrates how an input, which is the button press, causes the microcontroller, the Arduino's brain, to process information and then create an output, which in this case is the LED turning on or off. And this is exactly how your soil moisture sensor, which is an input, will tell your ESP32, the brain, when to activate your water pump, which is our output.
Now that you understand the purpose of your microcontroller, let us now take a closer look at the connections that make up your water pump and MOSFET setup. These are the wires that let your brain talk to the muscles. Your water pump and MOSFET have 4 key connections. 3 are on the lower power side of your MOSFET, and the 4th connects directly to your water pump.
The first is the power wire, which is often red on your MOSFET. Similar to what we discussed with sensors in Module 3, this is where the main electrical current flows into the MOSFET to power the pump. The second is the ground wire, usually black. Again, just like with sensors, this is the pin that allows electrical current to flow out of the MOSFET, completing the circuit safely.
The third is a signal wire, often labeled yellow or green. This is a special digital pin that gets an on or off command directly from your ESP32 microcontroller. Finally, the Vout pin is where the main electrical current leaves the MOSFET and goes directly into your water pump, making it run. So, in this fourth module, you learned the role of your microcontroller as the brain and the role of your water pump as the muscles to your smart garden, how your MOSFET acts as the gatekeeper to your water pump, and the difference between inputs and outputs in your circuit.
In the next module, you'll learn some basic coding logic, if-then statements, and how to write a simple program for your garden. You'll also learn how to utilize AI to help you write code. Thanks so much for joining us on this journey, and we'll see you in the next one. Until then,